So let's talk a little bit in this video about radiation and living organisms. When we measure how much radiation is being given off by a substance, there are a variety of different types of units that we can use. Now, these are only some of them, but the Curie is one that is used relatively often. You can see another one that's in here that we sometimes see in AP, disintegrations per second. Roentgens talk about the amount of radiation that's actually deposited on tissue. This is the one right here, the Roentgen equivalent man, or REM, has traditionally been the one that we've used for dosage of radiation in the United States in the nuclear industry. And it's any radiation that has the effect of one Roentgen on living tissue. So this particular one takes into account what type of radioactivity it is. Is it alpha? Is it beta? Is it gamma? So different types of radiation will affect tissue in human organisms differently. But recently we've seen sieverts start to overcome REMs in certain areas, certain industries, as a measurement of the dose of ionizing radiation. It's defined as the equivalent biological effect of 1 joule of radiation per kilogram of body tissue. 1 sievert is equal to 100 REMs. So they're gradually, it seems, going more and more towards sieverts now, whereas it's been REMs for years and years. But we'll see what happens with that. Most of the information that is on this video will be in units of REMs. In the United States, you cannot work legally at all if you are under the age of 18 around radiation, whether it's to clean up in a nuclear power plant or to work around it in a hospital where they're doing x-rays, etc. You cannot be around it. The maximum legal dosage is 5 REMs per year or 100 millirems per week. They wear dosimeters. If you work in areas like this, that will help you keep track of how much radiation exposure you've had. Now, we all get some radiation. Some radiation is called background radiation just because of being alive on this planet. And you can see this table. I'm not going to go through this table. You can read it. There's a worksheet that's going to ask you questions about some of this. And there are areas on the websites that will let you calculate how much radiation you get per year. But you can see here how much radiation that you can get just from building materials that contain uranium and thorium, from cosmic rays, depending on how high you are above sea level. Just things from food that you'll get, carbon-14 that's present in all living organisms, stuff from fallout, from us testing nuclear weapons, chest x-rays, different kinds of x-rays will give you those amounts. So that's considered to be, I guess, background radiation would be the best way to refer to it. Now, acute single incident exposure information we got primarily from survivors of atomic bombs that were dropped on Hiroshima and Nagasaki in World War II. Now, if we're talking about chronic, which is occurring over time, acute, remember, a single incident all at once, chronic, recurring over time, was obtained from uranium ore miners, early 20th century radium watch dial painters. And this was kind of interesting. They would routinely dip their paintbrushes in radioactive radium and then shape the brush with their tongue so they could write with that really fine lines on the radium watch dials. And evidently it was pretty cool to have a radium watch dial painter come to your party for Halloween or whatever, because they would paint their teeth with the radium paint so their teeth would glow in the dark, which was way cool back then. Not so cool later as they kept having that chronic exposure. The greatest risk occurs in unborn children, and especially during the first trimester, because cells are growing so rapidly during that time that the radiation is going to affect them more. The faster the cells are growing, the more that radiation affects them, which is why fast-growing cancer cells can be zapped with radiation because of that. So looking at these exposure data, I'm not going to read through all this, but you can see what kinds of effects that you would see based on the rims of exposure that you had. Some people are affected more by radiation exposure than others. You can have individuals that can get 150 rims of radiation, and some will still appear perfectly healthy. They won't have lost any hair, anything like that. Others will have all kinds of problems from that kind of radiation exposure. Once you get high enough, everybody's going to get sick. And when you get high enough, it doesn't matter who you are, you're going to die usually within 30 days because the DNA has been affected in your cells. So these are just some effects from that acute exposure. Now, long-term effects from chronic exposure, you get bones. Marie Curie died from a type of cancer they think was linked to her work with radium. Although I have read an article that said she should have died much more quickly because it's a very fast acting type of cancer. Did she live for several years with this because of her work with radiation? So who knows on that? But you do get an increased risk of cancer, primarily leukemia. Children, they don't grow as fast, they don't grow as much. You can get birth defects, chromosomal abnormalities, and increased risk of mental retardation, especially for those who were exposed in utero, meaning when they were still in the womb. So those are some effects of radiation exposure on humans.